It's topic 5, an overview of the climate. First off, solar radiation and something called albedo. We'll talk about the natural greenhouse effect, global surface wind patterns, and the jet stream. With solar radiation and albedo, in order to talk about this subject, we need to talk about something called the electromagnetic spectrum. The electromagnetic spectrum is the different wavelengths. If you look down here, we have wavelengths of energy that are available in the universe. The most abundant energy coming from the sun is in the form of visible light. Visible light is a technical term. I know it sounds like English, but that's a technical term for this radiation that includes the colors of the rainbow. Red is a longer wavelength and purple is a shorter wavelength. We also have ultraviolet, and beyond the ultraviolet we have gamma rays and X-rays. That's even shorter wavelengths. And as you go in the other direction from sunlight, we get near infrared and then far infrared. Microwaves, TV, shortwave radio, and AM radio waves. The electromagnetic spectrum is radiant energy, the energy that radiates from something. Wavelength is from the crest to the next crest of the wave. If you have a long wavelength, you can see that that's less energetic than a short wavelength. So the most energetic part of this electromagnetic spectrum is up here in the gamma rays and X-rays that are beyond the diagram. Ultraviolet is pretty energetic. Purple and blue end of the rainbow is more energetic than the red part. And then as you get to longer wavelengths, it's getting less and less energetic. Obviously, the sun is a lot more energetic than the earth. It's producing a whole lot more energy, and that's because it's so hot. So this curve here is the result of how hot the sun is. Now let's talk about absorption and reflection, because that's important in the topic of albedo. Absorption takes up and stores energy, such as radiation or light or sound, without being reflected or transmitted. You can think about a sponge absorbing water. It takes up the water. That is absorption. Reflection, you know what reflection is. It's like what happens with a mirror. Reflection is a change in the direction of a wave, such as light or sound wave, away from a boundary the wave encounters. So we've got a reflection here. We've got some light hitting this object here, and it's bouncing off the mirror. Reflection. It's kind of a bouncing action. Transmit means to pass through. I know a lot of times people think of transmitting as being radiating something, giving it off, but no, it's passing through. Transmit, pass through, like a lens. Okay, so the light is passing through the lens. The lens is transmitting the light. Radiate means send out. So a lot of times people confuse transmit with radiate. Radiate is to send out the rays, like the sun radiates rays. This radiator radiates rays. This one's obvious. You can see the red light coming from it, but it's also radiating near infrared. This one is radiating near and far infrared. It's not radiating within the visible part of the spectrum, so we're not seeing that radiation. You can feel it when you put your hand nearby. Now notice you can see the radiator. Well, that's because it's also reflecting some light, but it's not radiating that light. It is reflecting that light, but it's radiating infrared rays. So let's look at what happens to sunlight as it comes to the earth. The incoming solar radiation is 100%. 51% is absorbed at the Earth's surface. Some of it causes evaporation. Some of it is in the form of infrared radiation. Some of it is conducted. Some of it is being turned into convection. Convection is where you have circulation of air or other fluids. 19% is absorbed by clouds, and 30% is reflected from the surface and scattered and reflected from the clouds. Earth's albedo is 30%. So this reflected light is involved with albedo. So albedo is the proportion or percentage of light reflected from a surface. Notice the clouds and the snow have a high albedo, and the ocean and forests have low albedo. This diagram is something you could study a little bit, and you can notice the different albedos listed here. Asphalt has a low albedo, 5 to 10% here. Clouds have a high albedo, 75%. Fresh snow, 80 to 95% albedo. That means that snow is reflecting 80 to 95% of the light that hits it. Notice that the water has a low albedo at a high angle and a high albedo at a low angle. Think about being out at a lake and noticing that the light is reflecting off the surface of the lake. That would be the low angle. But if you were looking straight down into the lake water, you wouldn't be able to see that reflection. Beaches and deserts have kind of a moderate albedo. Compare that to soil, quite a low albedo, depending on the color of the soil. If it's a black soil, it'll be low. And if it's not so black, if it has less organic matter in it, then it will be a higher number. Now, the sun is providing energy for life on Earth. Almost all life requires sunlight as its original source of energy. So radiation from the sun powers surface processes, including convection and movement of the atmosphere and ocean currents and things like that, but it also powers life. Here's the sunlight coming in, and we have plants that are producers. The first trophic level, they are absorbing sunlight and they are producing chemical energy from that sunlight. Most of that energy from the sun is lost in the form of heat. Then critters come along and munch on those plants, and they are absorbing some energy from the plants and using that. And again, that's a chemical energy. About 90% of it is lost as waste heat. The next critter comes along and eats that critter, and it can only get about 10% of the energy from that critter. That means about 90% is lost to the environment. And then finally, our fourth level here, fourth trophic level, tertiary consumers, the top carnivores, they would be only getting 10% of that energy. So by the time you get up to those top carnivores, there's not a whole lot of energy left. Detritivores are critters that are using the waste from different organisms, and they get more energy than each of these individual steps. Now remember the spectrum of the sun I showed you earlier? It's mainly visible light. Visible light. Why don't you say the words visible light to yourself? I want you to say, in fact, say it out loud, because I want you to remember that term, visible light. It's very important, and that is the technical term. I find that students remember words like ultraviolet and infrared. Oh, they sound so technical. And that's true, they are. But visible light is also a technical term, and I find that a lot of students forget that one. So if you say it out loud to yourself, say it out loud, go ahead. That will help you remember visible light. Okay, notice 44% of sunlight is visible light, and it's a lesser amount for near infrared, and really only a very small amount in the far infrared, but a pretty small amount in the ultraviolet also. Sun's radiation reaching the Earth's outer atmosphere. Now, if we look at the sun spectrum at Earth's surface, we find that it's not quite so smooth, right? There's the outer atmosphere curve, and here's what actually reaches the Earth's surface, and that's because the atmosphere absorbs these different rays. So the red shading is at Earth's surface, and the yellow is what is absorbed by the atmosphere. Notice down here I've changed the units of wavelength. At first they were in nanometers, and now they're in micrometers. A micrometer is 1,000th of a millimeter. Very tiny little thing, 1,000th of a millimeter. Or 1,000,000th of a meter. A meter is 39 inches approximately. Okay, this also is the sun spectrum, and the colorful part is the part that's reaching Earth's surface. So this is the sun spectrum. Notice that this is the Earth spectrum. The Earth is giving off wavelengths within the far infrared over here. Let's go to the Earth spectrum. Here's the Earth spectrum, and notice that there are some gases in the atmosphere that are absorbing parts of the Earth spectrum, especially carbon dioxide. Now, you're familiar with these gases because these are ones that we studied in Lab 1. This radiation here is the radiation coming from the Earth because of its temperature. It's called black body radiation or black body emissions. And this is based on the fact that the Earth is warm. It's not as warm as the sun. The sun is super hot, but the Earth has some temperature, and that temperature dictates how much radiation it gives off. But the Earth is Earth's atmosphere is absorbing some of that radiation as it's leaving the Earth's surface. That's going to be important when we talk about the greenhouse effect. This diagram is the measured, these lines here is the measured radiation coming from Earth's surface. It's measured by satellite. The numbers here is wave numbers, just 1 over the wavelength. Here's the wavelength numbers. It's another diagram showing you Earth's spectrum and the fact that different gases like water vapor and carbon dioxide and ozone and methane are all absorbing parts of Earth's spectrum. Again, measured by satellite.